Welcome back. Will you please get your name and number on this page? Again, it's page 327. All right, we're going to go back to a quick little review about what unit cubes look like in layers, and then we'll be practicing a lot of real-life rectangular prisms. Okay, so it says you can use layers of cubes to build rectangular prisms. Each layer of these rectangular prisms is 4 cubes by 2 cubes. How many cubes make up each prism? So we're just going to answer these questions. So if in this one layer, it says it's 4 by 2, so it has 4 going across and 2 going back. That makes sense? So how many would there be if it's 4 times 2? There would be 8 cubes in that layer. So take a look. Now they've taken this layer and they've stacked another layer underneath it. So in 2 layers, right now what you have is you have a 4, a 2, and a 2. So if one layer was 8, 2 layers would be 16. If one layer was 8, 3 layers would be, well, you take 3 times the 8, 24. If one layer is 8, then how many would 4 layers be? 4 times 8 is 32. Okay, what about 5 layers? 5 times 8 is 40. And what about 6 layers? 6 times 8 is 48. So you can kind of see how they just kind of stacked, they kept stacking more and more layers. And eventually we got to 48 unit cubes. Okay, so now we're going to follow this part. The volume of a prism is the number of cubes needed to build the prism. We know that. Whatever the volume is means that's how many little tiny cubes could fit under there. Or in there, excuse me. Fit tightly in there with no gaps and no overlays. Remember? Fit tight. Okay. It says volume is recorded in cubic units, so they've already labeled all of them for us, so that's nice. So they're telling us if in one layer it has 4 by 2 by 1. That's exactly what this one is. Look, 4 going across, 2 going back, and 1 going up tall. 4 times 2 times 1 is 8. So in one layer there was 8. So what if in 2 layers, 4 times 2 times 2? Well, that would be 8, and 8 times 2 is 16. So you're just going to keep doing 4 times 2 is 8, 8 times 3 is 24. These are all of the same numbers that they were above. Remember, in 6 layers we have 48. Let's just double check that our math worked on all of these. Is 4 times 2, 8 times 3 is 24? Yep. What about 4 times 2, 8? Is 8 times 4, 32? Yeah. All of these 4 times 2 are going to be 8. Go ahead and write that. And it was 8 times 4, 32? Yes. Is 8 times 5, 40? Yes. And is 8 times 6, 48? Yes. All right. Turn the page. Isn't that so awesome? Oh, volume is so awesome. And looking at a page like this might be overwhelming, but it's really not. It's pretty awesome. Okay? The very first thing we're going to be doing is we're going to be finding the length. So we're going to take this whole, this is called a column, that we have to find and highlight it in red because and this one, because we've been doing lengths in red. What color have we been doing widths in? Yellow. And what color have we been doing height in? If you said blue, you were correct. So these first 3 columns are all about just being able to look at a shape and find the length, width, and height. Then we're going to put it all together. We're going to show what the equation is or what the mathematical situation is, and then we put it as the volume. And they want it as, they just wrote cubic feet. They represent cubic by just CU. I'm okay if you do that. Or if you, I like to write out meters, or I even like to do the little 3. Remember, I've showed you lots of different ways that this can be written. So we're going to kind of switch it up a little bit. Okay? All right, here we go. Here goes nothing, right? let's just go ahead and search for all of the lengths. How long is this shape on number 8? From left to right. Let's just take our red. 6. But we also have to put what the measurement is. So it's 6 centimeters. What about the length on this green one on number 9? What is that number? 12 centimeters. Okay, what about number 10? Use your red. Oh, sorry, not centimeters. It's meters on number 9. On number 10, it's 5. And what's the measurement? Inches. I think lengths are usually pretty easy to find, especially when they put them right there in front of your face. So I'm just kind of finding them on all the shapes. You can do the same. Ooh, what kind of shape do we have down here? A 6 by 6 by 6? This is a cube, friends. It's a cube. Are any of the other ones cubes? Nope, but it's still 6 inches for the length. Okay, let's pick up our yellow and let's go find all of our widths. How far back does the shape go? 15 centimeters on this one. The green one, how far back does it go? 4 meters. Number 10, how far back does it go? 4 inches. Pink one, how far back? 10 centimeters. And number 12, how far back does it go? It's a cube, so it goes 6 inches. Guess what? Even without looking, I already know that the cube's height is also going to be 6 inches. And just for fun, should we work backwards? All right, let's go number 11. How tall is this shape? 7 centimeters. How tall is this blue shape? 8 inches. How tall is the green one? 4 meters. How about the pink one? Number 8. How tall is that shape? From bottom to top or top to bottom? 10 centimeters. And they already did all of those ones for us. Okay, so now we're done with the colors. We found all of our length, widths, and heights. Now you can see how they did this on the example. They found the area first of one, which just means the length and the width. They did the length and the width, and then they multiplied it by the height. And I think I'm fine if that's what we want to do as well. It might be good for us to write them in that order. Anyway, but then I can see there's going to be ways that might be easier down the road. Just in general, but okay. Ready? So length times width. This one's going to be 6 times 15 times 10. Okay, they're just using parentheses to show you that you first find the area, then you times it by the height. The length and width times it by the height. So 6 times 15, I don't really know what that is, but I could probably do it. So I'm just going to come right here. They gave me plenty of space to work on this. It's 90. And I don't even think I have to show the final answer here. I just have to know that, okay, now I do 90 times 10, and that's going to give me my final answer over here. Remember, 9 times 1 is 9, and then you had 2 zeros. So it's 900, and this time let's do the little baby 3. No, let's actually write out cubic centimeters. The next time we'll just do a little baby 3. Does that make sense how we're doing this? Okay, number 9. So we do, in parentheses, we're going to find the area, 12 times 4. And then I'm going to times that again by 4. Because it's length times width times height. So what was 12 times 4? It's 48. And then I'm just going to stack this other number 4 right here. And 48 times 4. So 192. And this time we're going to do the little baby 3s, just so we get used to writing volume with all sorts of different ways. You can do it like abbreviate cubic. You can actually write out cubic. You can use the little baby 3. Lots of different ways to do this. Okay, number 10. 5 times 4 times 8. This one's pretty easy. 5 times 4 is 20. 20 times 8. Don't panic if you don't know. You just do 2 times 8. And then you add what? A 0. 2 times 8 is 16. And then there's a 0. And then what's the measurement? Inches. Let's abbreviate like they did. Okay? Cubic inches. All right, this next one we're going to use the little baby 3. Here we go. 15 times 10 times 7. That's 150. And I'm going to times that by 7. $1,050 centimeters cubed. All right, why don't you try this last one on your own? See if you can finish it all the way to the last box and circle your answer if you're confident. Keep working on it. Lots of 6s that you're dealing with. Be careful. I'm going to use the little baby 3. It's just faster, but you can do whatever you want. Only circle if you're confident. Make sure you did 6 times 6 times 6 and that you added correctly and multiplied correctly. Here's the answer in 3, 2, 1. 216 inches cubed. Did you get that? Okay. I really, really love this check your understanding. It's pretty interesting. So, sorry, it just says check understanding, but here's what I like about it. It says, explain how the dimensions of a rectangular prism are related to its volume. We're just going to talk about it. We're not going to write it out. But what it's saying is, when you're finding the dimensions for a rectangular prism, these numbers, 5, 4, and 8, here's how it relates. Let's just look at this blue one for a minute. I'm going to zoom in. I want you to put one finger on the blue shape. I'm looking around on number 10. Everybody put one finger there. Okay. It means that I could have this 5 inches right here. It means that the unit size of cubes that go inside of there are little baby inches. That's teeny tiny little dice. It means that 5 could be stacked this way, 4 could be stacked that way, and 8 could be stacked up tall. So it means that in the layer, there's 20. There's 5 times 4. There'd be 20 in every layer. And then the height is how many layers there are. Pretty cool, right? So it means there would be 20 in every layer. And how many layers? Well, it went up 8 times. There were 8 inches. So it's 20 times 8. Same thing with this. Look at the green one. Put a finger on number 9. On number 9, it means that 12 went across, 4 went back. So how many were in a layer? 48. So in one layer, there's 48. But I don't just have one layer. I have 4 layers. So it's 48 times 4. Look what we ended up doing. Wow. Everybody say, right? It's pretty awesome. It's seriously awesome. Okay, now comes the awesome task that you have to get a pair of scissors and a glue stick to be able to put this in your journal. The entire thing we're going to put in our journal. So we're going to have to narrow it down as much as we can, but I want you to keep the calculate volume. So let me show you what I mean. We're going to cut off the bottom. We're not saving the check understanding. I'm going to cut off the sides all the way as small as we can, making it as skinny as we can. So mine looks like this right now. I want you to keep the calculate volume, but you don't need to keep the green. And then you're trying to make it as skinny as possible in order to fit this into our journal. So I kept, so it looks like this. Calculate volume and complete the table. Then I'm going to turn in my journal. I'm going to turn the page of all the work we have done earlier. Looks like this. I'm going to turn the page. Make sure when you glue this in that you're not covering up any of the holes. And that's, I think, what I'm worried about. Oh, as long as you made it as skinny as possible, you'll be just fine. Try not to let it cover up the holes and get that glued in or taped in. Take a couple of seconds to do that right now. If you can't finish by the time I'm done, then you're going to need to pause the video. But please listen while you're getting all this done. When you find the volume of a shape, you are not finding something that's flat. You are finding things that can be stacked and fit tightly inside of a three-dimensional shape. In our case, we've been learning how to do it with rectangular prisms. But there are way more shapes out there in the world that are not rectangular prisms, but they are the most common shape. Think about all the Amazon boxes that might come to your house. Well, I should say my house, because Amazon's my best friend. Think about cereal boxes, shoe boxes, pencil boxes. Those are rectangular prisms. But there are some shapes out there that are not rectangular prisms. And eventually, when you grow up, you are going to be able to find the volume of those types of shapes as well. So you have to learn this one first in order to understand what's to come. So congratulations on the first step of learning volume. I hope you've enjoyed it. We're not even done yet. But I am ready to move on. So if you're not ready, you'll have to push pause on the video. We are done with our journal. It will come in handy today, though, if you want to take a look at the homework with it. But you can go ahead and put your journal to the side. And I think it would be important for you to pull out your homework for today. Don't forget that everybody has Think Central for Unit 8. That's just the extra practice problems when it comes to volume. So please, when you're done with this math journal video, please check Think Central. I think I would do Think Central before I even do the rest of this. So you're going to look at layers on 1 through 4. And when you're looking at layers, remember we're looking at like the top layer. We're going to cut off. I'm just going to use my red here. We're going to cut off that layer. That is what we're talking about with a layer. Okay? And then you're going to answer all these questions. When it says write a multiplication expression for the volume, you're just going to find, well, there's 4 that go over, 4 that go back, and how many went up? 3. So it's 4 times 4 times 3. Anyway, these are going to be super easy for you because you know how to do this. You're going to know really well how to do this. You don't need to use your crayons. I'm just going to let you go for it, but make sure you multiply them in the space here and don't go so fast that you're making little mistakes. Also, it makes me really sad when people don't put the measurement because they get the whole thing wrong. So make sure that when you find the answer, you're also putting inches cubed, centimeters cubed, inches cubed, meters cubed, feet cubed, yards cubed. You really need to do that. Okay? If you want, you can do that part quickly before you move on. But this will be so helpful too if you'll go to the remembering side. The order of operations feels like forever since we've done that, but it hasn't been forever. Everybody needs to write PEMDAS. Don't forget that the addition and subtraction are connected and multiplication and division are. So when it comes to that, these two, the M and D, you're going to do whichever one comes first, left or right. Same with the addition and subtraction, left and right. Okay, so number 1, I have subtract, add, subtract. Well, they're connected. So you don't search for the addition first. You just do whichever one comes first, left to right. In fact, I'm going to write this right here. These circular ones mean left to right. So in this case, I'm just going to work left to right because all I have is subtract, add, and subtract. So I'm just going to do carets as I go. 21 minus 6 is 15. 15 plus 3 is 18. And 18 minus 6 is 12. Final answer gets circled. That was probably the easiest one, so you're welcome. I'll do, I think number 2 is a pretty cool one. So it has parentheses, right, which means you have to do those first. So I'm going to solve these parentheses, and then I'll multiply those together. Okay, 7.9 minus 5.1. I'm actually not going to put the caret there because I'm just going to stack it up. They're decimals. So you have to subtract them by lining them up. Remember the Button Man song? Do you know the Button Man, the Button Man, the Button Man? Do you know the Button Man? He lines the decimals up. So inside of this parentheses, wiki, is 2.8. Okay? And I'm supposed to multiply that by whatever those two are added together. 0.2 plus 0.8. Well, I can do this in my head because I know what 2 dimes, 2 tenths, and 8 dimes, 8 tenths make. But I want you to prove it. So stack them up. Decimal. Ooh, 1.0. What is 2.8 times 1.0? What is 1.0? Just 1. So 2.8 times 1. So awesome. So awesome. Okay, what do you do here first? Multiply or divide? Well, they're connected, so it's just whatever comes first. So you're going to do this one first. Then you're going to bring it to here. 60 divided by 5? I have no idea. Do you know what it is? Okay, so if we don't know, we're going to go like this. 5 goes into 6 once. Oh, we should have known this. I just wrote that it's 12. Oh, this is hilarious. I should have thought this through. You should think this through. 60 divided by 5 is just 12. Guess what I'm doing? I'm not making it super messy. I'm coming back to kind of where the problem is and writing the answer. See that? Equals 12. That's because I'm being nice. Okay. Number 4, I think this one's super interesting. What do you do first? Multiply or divide? They're connected, so you just work left to right. So you're going to do this one first. 1 times 1. Remember when you multiply fractions, you just go straight across. So 1 times 1 is 1. 5 times 5 is 25. So I get 1/25. Then I'm supposed to divide by a fifth. Ooh. Let's see if you remember this. To divide by a fraction, here's a tip. Keep, change, flip. Keep, change. How do you flip 1/5? It becomes 5 over 1. And then I just extend the bar. 1 and 1, they're diagonal. They cross each other out. 5 and 25 can both be divided by 5. 5 divided by 5 is 1. 25 divided by 5 is 5. So I put it there. So my answer is 1/5. So I come close to where I'm at. That's so funny. Oh, you know what is so funny about that? Is I didn't even think about it. Listen to how crazy this is. If I have a number and I times it by 1/5 and then I divide it by 1/5, I basically just reverted it back to what I started with. Here's my number, times it by a fifth, and then divide it by a fifth. Take it back. That's a take it back action. So I should have just thought that through. Let's just say the numbers were 2 and 3, right? If I did 2 times 3 and then divided it by 3, you're going to get the same number you started with. That's pretty funny. I'm going to let you figure out how to do number 5. You can't subtract these unless you stack them up because they don't have the same denominators. So stack them up and change them so they have the same denominators. So you can't subtract fourths from eighths. So they're going to make that one into an eighth. How did I get from 4 to 8? I times by 2. And 1 times 2 is 2. I'm just showing you how that worked. Wiki wiki. So I have 3/8 minus 2/8 is 1/8. And then 2 minus nothing is 2. So I have 2 and an eighth. And now I'm supposed to times it by an eighth. Well, you can't multiply a mixed number by a fraction until you change it. Multiply, then add. 8 times 2 is 16, plus 1 is 17 over 8 times by 1/8. None of these have relationships, so it's just going to be 17/64. That is crazy. But that is your final answer. Isn't that so crazy? 2 and 3/8 minus a fourth. I'm just going to go back and check. 1/4 is 2/8, so I subtracted that to get 1/8, and then I have 2. In order to multiply it by an eighth, I have to multiply then add. 8 times 2 is 16, plus 1 is 17 over 8. Yep, you don't flip anything because it's not dividing, it's timesing. We did it right. Go us. Number 6. What happens? Subtract or multiply? Multiply, and they're not connected. So you're going to do that part first. Okay. How do you do this part? 3 times a 16th. You put a 1 underneath it, extend the bar, multiply straight across. Well, 1 and 1 cross each other out, right? Because relationships. So it's just 3/16. So I have 5/8 minus 3/16. I'm just going to stack it up over here. 5/8 minus 3/16. You cannot add and subtract fractions if they don't have the same denominator. So you have to make them have the same denominator. 16 and 8, I already told you what it is. I wrote it right there. 16. How did I get from 8 to 16? I times by 2. And 5 times 2 is 10. Wiki wiki. And then I do 10/16 minus 3/16 is 7/16. Final answer. Cool, huh? We're cruising. Number 7. Whoa. Divide, add, divide. What comes first? Divide. Well, and there's 2 divisions, so you technically have to do that. You have to do 2 sets of division, and then you can add them together. Okay. 16 divided by 0.2. Looks like this. 16 divided by 0.2. You can't leave a decimal out in the divisor, so you have to multiply it by 10 to the first power. Excuse me. When I multiplied this one by 10 to the 6th power, 10 to the first power, I also have to multiply 16 by 10 to the first power. So I end up getting a 2 as the divisor and a 160, because 16 times 10 is 160. And then 2 goes into 16 8 times, so it's 80. So this was 80. I'm going to be doing 80 plus something. Okay. 15 divided by 0.03 looks like this. If I have to move this one twice, then I have to move this one twice. Right? It's by 10 to the 2nd power. That is a little multiplication sign. It looks like I'm going to have to put this by 10 to the 2nd power. So that equals 3 is the divisor and 1, 5, 2 zeros. 3 goes into 15 5 times, 2 zeros. So 80 plus 500, what does that equal, everybody? That is what it equals. Pretty crazy. I love doing math like this. You are having so much fun probably doing this with me. You're welcome. Okay. On number 8. Yeah, I'm still going with you. Isn't that nice of me? Number 8. If I'm given parentheses, I must do that first. So I'm just going to stack them up. Go ahead and add those together. Do you know the button man, the button man, the button man? Do you know the button man? He lines the decimals up. Whenever it's 8.0, I always just like to say, okay, so it's 8. Right? That's what's inside of there is 8. Okay, Ricky. So now do I do the division or the multiplication? Well, they're connected, so you work left to right. So I go, okay, 64 divided by 8 equals 8. And 8 times 2, 16. See, not so shabby. I love order of operations. Number 9. 0.7 minus 0.9 divided by 3 plus 0.6. Lots of things are happening. I have a subtract, divide, add. Which one of those comes first? Divide. So I get to put the parentheses in. 0.9 divided by 3 looks like this. Always the first number goes inside the box. A little bit different. The decimal's not on the divisor, the decimal's in the dividend. So I move that decimal straight up into the quotient. 3 doesn't go into 0, so I'm just going to put a 0 there. Or you could put an X, whatever. But 3 does go into 9 3 times. So this is 0.3. Okay. So do I do subtract or add now? They're connected, so you work left to right. 0.7 minus 0.3 is 0.4. 0.4 plus 0.6. Remember, they're decimals, so you should line them up. Think about it, though. If you have 6 dimes and 4 dimes, don't you have a whole dollar? Yeah, but we're just going to stack it up just to help you remember. Do you know the button man, the button man, the button man? Do you know the button man? He lines the decimals up. So 6 plus 4 was 10, so I dropped the 0 and carried the 1, plus had the decimal, and that's 1. So my answer here, so I did 0.7 minus 0.3 is 0.4. Then I took it and added it to 0.6. My answer is 1. After all that work. Isn't that crazy? So crazy. So fun. You don't have to do stretch thinking. You're welcome for that. But I do want you to do, obviously, number 10 and 11. That's super easy. Plus, you have to do all of those, but they'll go really quickly. This is why you have a Think Central assignment today. But I do want you to do one more problem for me. Okay? So at the very bottom of Stretch Your Thinking, I want you to write out PEMDAS. And here's the problem. So this is the star. Like, you have to do this problem. And if you didn't watch all the way to the end of this journal video, we'll know, and your grade will too. So make sure that you know you need to do this problem. Okay? You must do this. You ready for it? You must do this order of operation problem, which that's what we're talking about when we're talking about PEMDAS. It's called the order of what? Operations. Okay, here we go. Ready? The problem is 5 plus, and then put in parentheses, 21 minus 6, close the parentheses, divided by 0.2. Again, 5 plus, in parentheses, 21 minus 6 divided by 0.2. You are going to solve this problem because I just helped you out with a whole lot of homework. You're welcome. So first thing, get on to Think Central. Do the assignment for 8.5. Next thing, come and finish the remembering page. You got 2 problems here plus the one I had you do. So you have 3 problems there to do. Then turn it over and do the easiest side of all, the homework side. I hope you are loving learning about volume, and we'll catch you next time.